Hello everyone, let's resume our class of foundation engineering. So we are still on the review of soil mechanics, and for this video we will talk about strength of soil, and this specific section number 4 of this chapter is a little bit long, but we will try to make it with several videos. Okay, strength of soil. In foundation engineering, as you know, there are two engineering parameters that are very important for foundation engineering. These two parameters are the strength of soil and the compressibility of soil. These two soil properties are very critical in foundation engineering. And I think not only in foundation engineering, in geotechnical engineering. Here it's saying foundation engineering, but in all geotechnical projects, these two are very important. Okay, so the soil is not strong against tensile force. So if you pull traction, soil cannot support traction. Okay, and soil passes substantial compressive strength. That means if it is compression, maybe soil can support more than when it comes to traction. Okay, and in case of compression, the failure mode of soil is mainly through shearing. Okay, so shearing is the main failure mode of soil, not compression, as many people think that the failure of soil is through compression, but actually it's mainly predominantly through shearing. Okay, so in that case, the shearing strength of soil or shear strength of foundation material is a key factor in designing foundation. Okay, because we know that the failure procedure, the failure mode of soil is shearing failure. So we need to know the shearing strength of soil. Okay, that will determine actually the bearing capacity of the soil. Okay, so as I told you, the fourth section of this chapter is a little bit longer than the previous one, and we will divide it in the relatively shorter part, so subsections. So as here, this slide, we will talk about this subsection, drained and undrained stem. So I hope you understood first that the shear strength of the soil is very important in foundation engineering. Okay, so drain and undrained. Drain, we are talking about the drainage of water. Okay, yeah. So shearing strength of soil is attributed to cohesion and internal friction angle, C and phi. These two soil parameters are the main parameter that determine the strength of soil, shear strength of the soil. We have what we call Coulomb's principle of friction, that is used to determine the shear strength of the soil it from this formula. This tau F maybe C plus sigma n tangent phi, tangent phi. Phi is in French. Tangent phi. Okay. This is the formula of the shear strength of soil. Okay. So this sigma n is the normal stress on the failure plane. Actually, this part is well detailed in soil mechanics class. But I suppose that if you are here in foundation engineering, it means that you know already about all this. So this is just a reminder. So intensive study, some people did investigation and they found out that this the most consistent and reliable strength parameter are obtained when we use this equation 110.6 by using effective normal stress. Means sigma. I think in the previous video we have talked about effective stress, total and effective, total stress, effective stress. So effective stress is the part that the soil particle are supporting. Okay. Yeah. In the previous video, we have talked about this. When we have water, especially when we have water in soil, one part of the load is supported by the water and another part is supported by the soil particle. Okay. So effective stress. So by using in this formula, instead of using total normal stress, it is suggested to use effective normal stress so that you can obtain consistent and reliable strength of your soil. The strength parameter. Okay. So this lead, because if you are going to effective one, primary, it will lead to cohesion and internal friction angle being referred to as effective strength parameter, because the first point here is saying that these strength parameter are cohesion and internal friction angle. So effective one will be C prime and the phi prime. Okay, effective one. Like sigma prime means effective stress also. So these parameters are relevant in drained condition without poor water pressure. Okay. So it will be then the resulting failure load computation are suitable for construction situation without significant poor water pressure or with sufficient time for poor pressure dissipation during construction. Like if during construction, because if you have, when you have water in soil, after loading, and you start loading the soil, water will start trying to escape. Okay, water is escaping because water is incompressible. We cannot compress water. Okay, means we cannot reduce the volume of water. So the void in the soil, if those voids are filled of water, if you load on that soil, the water will try to escape. So if you leave that load for a long time, or if your construction will take a long time, then the water will have time to escape but slowly. That's the meaning. Okay. So construction situation without significant poor water pressure. That means maybe you almost don't have water. The amount of water is not significant. Or in case you have water, then the construction speed will allow the water to escape little by little. Okay. I will keep this formula here as you know, after finishing with a formula, maybe not finishing, but after establishing a formula, we keep it in this corner. Okay. We might need it again. So effective strength parameter can be obtained from undrained shear test, sharing test, undrained sharing test by monitoring pore water pressure during the sharing. And in that case, we can use this equation 6 with effective normal stress. Okay. This parameter, the effective strength parameter, means C prime, so phi, C prime, I'm speaking Japanese now. C prime and phi prime. These two can be obtained from undrained sharing test. Okay, we will talk about this undrained share size test later. Maybe in this video a little bit, but next video also more. So monitoring the pore water pressure, okay, triaxial test, for example. Okay, but if you use this equation 6 with the total normal test, like in this case, like this, in undrained shear test or shear tests, yields different strength parameter known as the total stress based parameter. So generally lower in magnitude than effective one. Means if you use, the magnitude will be less than effective stress. So this align with, we will talk about this more in section 8 of this chapter. As a reminder, we are here section 4. Okay, and stress path also. So the measured shear strength of soil sample is influenced by pore pressure generation. Okay, the pore water pressure is influencing the measurement, your experiment. Okay, but these pore water pressure are also dependent on the drainage condition. Actually, it's difficult for you maybe to understand if you are new in this, but for those who know Triaxial Test, maybe they know what I'm talking about. So pore water pressure can be controlled with drainage condition. Soil type also, loading rate. I think for the loading rate, I have already explained it during construction. If your construction is your building slowly during very long time, that will influence the drainage condition of the soil, or of the water in the soil. Yeah. So the type of soil also, of course, will have influence of the drainage condition. Okay. For example, if you have sand and if you have clay, the drainage condition will not be same. Okay, so the type of soil and loading condition, loading rate during construction. These indirectly influence the choice of laboratory drainage condition for testing. This means when you are doing test in lab, you try as much as possible to put your sample in the same condition, in situ condition, the drainage condition, and the field, construction field. Try to put the soil sample you are testing in the same condition. Yeah, soil type and loading rate during your construction. Those two will determine the drainage condition you will choose in your laboratory test. That is the main, okay? Because you need to know how, after construction your foundation, how this will affect the soil. Okay. First, because in any construction, civil engineering construction, the first thing is building the foundation first. I mean, of course, there are a lot of study before that, but you have to start with the foundation. So you construct the foundation, and if, for example, you have 10-story building, when you are first floor, second floor, before completing this building, from the beginning, the early beginning, load is already acting on the soil through the foundation. So how how this load will affect the ground condition, the stress in the soil, and indirectly the water in the soil. Are you loading very fast? Your construction is your construction very fast or relatively slow? Okay, so maybe long term or short term, something like that. Yeah. Anyway, there are many laboratory tests, various laboratory and field technique that are used to assess the shear strength parameter, means C and phi of soil. Okay, so common method include triaxial test. That's what I was talking about. Another one, direct shear test. Okay, so apart from these lab tests, we have also in situ standard penetration test, SPT, and static cone penetration test. Okay, the cone penetration test, CPT. I think SPT is used in Japan, but CPT is used mainly in Europe. This one, when shear testing. Okay, all these tests can be used to determine the strength parameter of your soil. But these parameters are vital for you to determine the bearing capacity of your soil before constructing any foundation you want to construct. Okay, so of course we will explain how to obtain these parameters by using these tests later. Okay, each test has own procedure. So this chapter will focus mainly on triaxial test approach, this one. Okay, so how to evaluate this strength parameter of soil using triaxial test. This chapter will focus on this. So for SPT and CPT, in the next chapter we will give more detail about these two. Chapter number 2. So triaxial test is then, okay, in this chapter we will give more detail. In this video we will talk a little bit, just introduction of triaxial test. Next video will give more detail about this triaxial test. Triaxial test for soil and triaxial test for rocks also, because foundation is not only on soil, foundation also in rock, on rock. Yeah, triaxial test evaluate undisturbed soil sample under various cell pressures. That this is like trying to replicate the foundation stress condition, like in situ condition, how the soil will feel, will how the soil will receive stress in situ. Okay, so this is this triaxial test will try to do that. This machine I showing, this is just drawing. A is drawing schematic diagram, and this B is photo from Wikipedia. So this is the apparatus for triaxial test, and the soil is inside, and the soil sample is actually covered with plastic membrane. So the cell fluid in the cell, the load is applied here using this axial loading term. Okay, and of course we have to let water, porous water, because the sample is covered plastic. So around the soil sample, we can apply stress by using the fluid in the cell fluid, and this is the drainage condition. We can control the drainage. This is like a van. You can open or close, something like that. So this captain propose two parameters A and B to quantify potential pore pressure change during this triaxial test. How the pore water pressure will change during the triaxial test. Okay, so the formula is something like this. The A is here, the B is here, and delta sigma 1, this one, delta sigma 1, delta sigma 3 are increments of the major and minor principal stresses, respectively. Okay, for those who have studied soil mechanics, they know what I'm talking about. So I think if you need more detail, please again check for the soil mechanics class. I put this formula here, this Skepton parameter used in the formula. So this triaxial test is the apparatus shown here in this figure. The primary vertical compression test stress is combination of the axial stress, which is also deviator stress, from vertical load, this load, plus the vertical confining pressure, means the confining pressure coming from the cell, the fluid cell, okay? We can use that fluid cell to bring pressure on the soil sample. So the load, that load, please plus the confining pressure, because the confining pressure is acting from every direction. Okay, so vertically also that confining pressure will act. So confining pressure combined with the vertical load, the stress from vertical load, that will give primary vertical compression stress. And the vertical confining pressure, vertical confining pressure, the vertical component, that is the primary sigma 1. Okay, the minimum principal stress is the horizontal confining pressure. I'm not sure if you understand this. Mean the soil sample is inside. The chamber you are seeing here, this fluid inside, we can use the fluid inside to apply pressure. The pressure of that fluid can be monitored also, can be changed. So the pressure from the fluid will act on the soil sample from everywhere, from all directions. Okay, so what we are calling primary vertical compression stress means sigma 1 here, the major one, the major stress, sigma 1, is the stress from the fluid cell phase plus the vertical stress, the stress from the vertical load. Okay, that is the principal compression stress. The second one, the minor one, is only the fluid cell. Maybe will act, yeah, from everywhere, of course. That is the meaning. Horizontally, this way, but the value is equal to the cell fluid pressure, confining pressure. So by determining this coefficient A and B, the Kepton's parameter, through preliminary triaxial tests, we can predict the pore water pressure changes in different stress conditions for a given soil type. For saturated soil, this B can be taken as 1. So another alternative to express this pore water pressure, the pore pressure increase, the variation of the pore pressure in the triaxial loading is expressed by this formula. So delta sigma oct plus 3 times A, the delta tau oct. So this A, this one, is the Henkel's pore pressure parameter. Okay, and this delta sigma oct and delta tau oct are octahedral normal and octahedral shear stress. So the formula of these two are given by this one, this equation, and this equation. So this one is sigma 1 plus sigma 2 plus sigma 3, and we divide it by 3. This is mainly from soil mechanics 2, not soil mechanics 1. And this tau is given by this expression. Okay, sigma 1 is the major one, sigma 3 is the minor and intermediate sigma 2. But in triaxial test, sigma 2 and sigma 3 are equal, same. Okay. So in that case, in the case of triaxial test, as I explained, since sigma 2 is equal to sigma 3, then we will have this expression because this is equal to this. Okay, sigma 2 is equal to sigma 3. Then we can say that this formula becomes sigma 1 plus 2 times sigma 3, because we can say that this sigma 2 is equal to sigma 3 in case of triaxial test. Okay, and this one also becomes like this from this formula, so we can simplify it. Very good simplification in case of triaxial test. Okay, I put back this formula here. In case of triaxial test, we can simplify this in here like this. I think we will give more detail about this too later. So anyway, we have 3 types of triaxial tests and classify or based on the drainage condition, because as I told you, the soil type you have on your construction site and the loading speed on your construction site, those two indirectly will guide you to monitor your drainage condition in your lab test. So consolidated drained triaxial test, CD. C standing for consolidation, consolidated, and D is standing for drainage, so drained. Consolidated and drained triaxial test. Number 2, we have consolidated and undrained triaxial test, that is CU. And unconsolidated, undrained test. So not consolidated, but not drained also. Okay. So this CD and CU, these two, the first two, because of consolidation, consolidation, it means before applying the axial compression, before bringing load from here, before applying the load here, because the load is coming from here. This one is the load. Okay. Before applying the load, the confining pressure is established. Okay, using this fluid, the cell fluid, means you confine the soil sample. It's like the soil sample will feel like it is in city condition. Okay, then we apply the load, but you have 2 choices. You can drain, you can open the van and water will go. Okay, there sometimes also there is air, but you can also undrain, means you. Okay, consolidated and drain triaxial test. Okay, this process consolidates the soil sample to its original in situ effective stress state. That is what I was saying before. So by consolidating, by putting the cell fluid pressure, the confining pressure, you can put the soil sample in the same situation as it was in the field. Okay, before sampling the soil sample. That is the objective of this confining. consolidating constantly. So if you check now this case, unconsolidated and drained, in that case, as the name said, unconsolidated, it did not consolidate it. Okay. So the cell pressure is applied without drainage or without consolidation. Okay. That is the difference between this one and these two. No, not drained and not consolidated. So I think for this video we will stop here. But for triaxial test, the next video also we'll talk about triaxial test in more detail, including triaxial tests in case of rock, not only soil. Okay. Yeah, thank you very much. So see you next time.